In this presentation, we'll review the architectural aspects of CEDAR and how CEDAR fits into the anticipated data architecture for the RADx Data Hub. The CEDAR Workbench runs as a web application service hosted at Stanford University's School of Medicine. Its many back-end stores and microservices are presented both in a user interface and via a REST API. The CEDAR Workbench user interface has three components: a Google-like desktop for managing and finding artifacts, a drag-and-drop template designer to create the metadata specifications, and an easy-to-use metadata creator which presents fillable data collection forms based on the metadata specifications created by the template designer. All of these components rely on a rigorously defined specification model, the CEDAR template model, that can be used to describe almost any metadata specification and can validate entered metadata against a described specification. CEDAR is designed as microservices, and these expose their functions via a well-described API. The API allows CEDAR to be integrated with other systems and to be queried for meaningful content. To talk about how this fits into RADx, we start with a simple description of the system architecture for the RADx project. The RADx Data Hub lives in a data environment that includes the RADx research projects. These projects generate data that are collated in the RADx Data Coordination Centers and Coordination and Data Collection Center. The data catalog contains descriptive metadata about data files and studies, and management of the collected data files occurs in the Data Hub. Finally, the Terra and Kavatica researcher workbench environments can discover, access, and process the data in the Data Hub without enabling any data download beyond the RADx environment. Describing the data files involves two kinds of information: the content of the data file and information about the data file as a whole. Data dictionaries describe the file content with data elements, questions, and the answer type or possible answer values that make up a particular data file. As a practical matter, each question addressed by a data file is like a data variable, and the answers are the variable values that make up the data file itself. Often, the data element definitions are called CDEs, for common data elements, though that term has a more formal meaning that refers to artifacts in NIH's CDE repository. Sometimes the term CDEs is also used to refer to the actual data values in a data file. We call descriptions about each data file the metadata for that file. For now, we don't include the data element descriptions as part of that metadata. In current RADx practice, DCCs may offer different metadata attributes, using different file formats and data structures, and using different or no controlled terms. They may even provide no descriptive metadata at all. This makes it hard or impossible to describe, find, understand, and use the data files. The resulting cost to researchers, including the original researchers providing the data, can be extraordinarily high. In both the data dictionary descriptions that contain the data elements and the data file's metadata descriptions, CEDAR supports harmonization and normalization of the corresponding information, even before it gets to the DCC or Data Hub. For the data dictionary and data element descriptions, CEDAR provides rigorous description formats. CEDAR fields capture the attributes required to define, display, or fill out a data element, and CEDAR templates specify collections of data elements. Putting all of these artifacts into a common format in a single system greatly improves their discovery and reuse, whether the artifacts come from multiple NIH repositories, other RADx projects, or other projects defined and shared in CEDAR. Soon, CEDAR will have basic compatibility with REDCap data dictionaries, further increasing the interoperability of these specifications that is available to RADx scientists. For the file metadata descriptions, CEDAR's template model codifies precise yet flexible rules for specifying the descriptions. Its template editor makes it easy to create rigorous and precise specifications using a friendly user interface. And the metadata creator allows users to enter the metadata easily and accurately by hand, or users can programmatically build and submit a JSON file that follows the specification. These CEDAR resources use semantic standards to ensure the metadata is easily defined and still will be understood within and beyond its initial science domain, by people and also by computer software. The initial goals for CEDAR in the RADx Data Hub focus on standardizing RADx data specifications and performing any straightforward harmonization of RADx data. By providing a uniform way to describe data files and contents, we will make it easier for data providers to share and publicize their data, and easier for the Data Hub to provide interoperable or AI-ready data files to researchers who want to reuse RADx data. Going forward, as we apply common metadata attributes and vocabularies to all RADx data, the entire Data Hub project can readily support more advanced searching, analysis, and promotion of RADx data for the widest possible user community.